question, go ahead and interrupt me. If I don't hear anything, I'll just assume everything is okay for this. All right, so the first question here for A says to determine the x-intercepts and the y-intercept. The y-intercept is a little bit easier, so we'll do that first. That's when x equals 0. You're putting 0 in for x. So that's f of 0 equals 0 squared minus 6 times 0 plus 5. So that is 5. It is an ordered pair. It's 0, 5. It is typically that last number there when it's in this format. If it's in the other format of a quadratic, then you do something else, right? For the x-intercepts, you're setting the function f of x equal to 0. And this is not the same as what we just did. You're putting 0 on the left equals x squared minus 6x plus 5. Some students don't like it on the left. I agree. It kind of looks weird there. So you can move that over to the right. And you've been solving quadratic equations like this for a while. So you have to factor this. So you're looking for two numbers that multiply to 5, but add to -6, x minus 5, x minus 1. Set it equal to 0. You're setting each term equal to 0. So x equals 5 and x equals 1, like that. So those are your two x-intercepts. They are ordered pairs, so it's 5, 0 and 5, 1. This f of x equals 0 from the beginning, that's the part where y is 0. And that's why y is 0 here. And sorry, that second one is incorrect. It's 1, 0. Y is equal to 0 there. So that takes care of part A. Again, if you got some questions, drop them in the chat or unmute, but we'll just move on to part B. So to find the vertex when it's in standard form, so what you're seeing over here on the left is standard form. That's the ax squared plus bx plus c form. The standard form here is x equals minus b over 2a. So b in this problem is the -6. -6 over 2 times a is the 1. So a is 1, b is -6, and c is 5. And then you have to simplify here. So 6 over 2 is 3. So that's the x coordinate of the vertex. Okay, to find the y coordinate of the vertex, you have to put x equals 3 or whatever number you get back in for f of x. You're finding f of 3 now. 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5, which is -4, it looks like. So your vertex is that x value 3 you just found, and the -4 there. So let me just color code that in case you want to look at that later. -4, -4. The axis of symmetry comes from the vertex. So it is always the x coordinate of the vertex. X equals 3. And it has to be written as an equation. I'll just, unless there's questions, I'll just keep going here. So just interrupt if there's something's unclear, unmute and jump in. But let's go down here and do part C here. So is the vertex a min or a max? So this would be for a min. This would be for a max. And it depends on A. If A is greater than 0, positive, it's a min because it opens up. If A is less than 0, it's a max because it opens down. So in your problem, we wrote that A is 1, which means that this thing opens up, which means it has a minimum. So when the instructor said explain how you know how, I think drawing a picture is enough, but then you might want to say a few words like since A is greater than 0, it has a minimum because it opens up. That would be sufficient for me. But of course, I'm not graphing this thing, or I'm not grading your problem, so go with whatever you've been seeing in class on that one. All right, write the function in vertex form. All right, so I'm gonna go grab the function here, f of x equals x squared minus 6x plus 5. I guess I do have to ask you a question on this one. Are you guys using completing the square, or alternatively, you can use formulas for this? If you could jump off your mute and let me know.
We do complete the square, I'm pretty sure.
Okay, thank you. All right, so completing the square here, unfortunately, is a bit of work here. You set it equal to 0, and you move this constant term to the right. So it becomes x squared minus 6x equals minus 5. And then I draw these red placeholders here because you're going to fill those in. We're going to put a number in both of those positions. That number is based on what you write down below. So you take this b value, -6, and you cut it in half. So that's x minus 3 squared. So you always divide by 2. To get this number that goes in the red box, you square the number on the right there. Since it's negative, when you square it, it becomes positive. If it were positive, it would stay positive. So that becomes positive 9. So plus 9 plus 9. So on the right here equals 4. Okay, and then you move this number back over by subtracting 4 from both sides. This becomes x minus 3 squared minus 4, and then you bring the f of x down, and now you have it in vertex form. So that's part D. So the next part here is to graph it. Well, you got a lot to do on this problem. All right, to graph it, you generally do a couple things. One is you start at the vertex. Let me just see if we were consistent here. Yeah, we were. Okay, so the vertex is 3, -4. So 3, -4 right there is the vertex. So what I show students, I think you'll like this approach, is you put the vertex right in the middle. Then you need 2 larger values of x and 2 smaller values of x. You don't just use 0, -1, -2, -1, 0, 1, 2. You go at the vertex, two larger, 2 smaller. Now, hopefully you've seen this in class where by symmetry, you don't have to do them all. Like you can just do 4 because the result of 4 is also the result of 2. Okay. Now to actually get these values, we have to put them into the function there. So let's try x equals 4. That's 4 minus 3 squared minus 4. Just putting 4 into x. 4 minus 3 is 1. 1 squared is 1. Minus 4 is minus 3. And by symmetry, this point up here is also minus 3. And what I mean by that, if we go to graph these, 2 minus 3, 4 minus 3, they're symmetrical about that line that cuts right through the middle of the parabola there. So now we'll try x equals 5. 5 minus 3 squared minus 4. That's 2 squared. 2 squared minus 4 is 0. 4 minus 4 is 0. And again, by symmetry, this is also 0. So I'm graphing those points. Usually they want 5 points when you graph, compared to your notes from class. You can also graph other points like the y-intercept, which I probably would do if it were me as a student, just because it's not that big a deal to add that point. And by symmetry, you've got another point over here. And then just a nice smooth curve, try not to use any straight lines. Put arrows at the end, something like that. So go ahead and unmute if there's any questions. If not, I'll move to number 5. I'll take your silence as let's move on to number 5. So here we go. I like that you've already tried this problem. That's great. Okay, so zeros of 1, that means x minus 1. That's perfect. X plus 2 for minus 2, and 5 with multiplicity 3. That's perfect. So one thing that I'll just add here that you might want to know is when the degree is odd, you probably already know this, but when the degree is odd, it crosses the x-axis. When the degree or multiplicity in this case is even, it touches. So you might see that in another problem here. The only other thing that could be under consideration here is sometimes there's an A in front, but you don't have enough information to find the A. But keep in mind that that could be something they ask. So if there's any questions on that, go ahead and unmute, and otherwise we'll move to number 6. All right, take your silence. That is to move on. All right. Okay, write a polynomial function that might have this graph. So I really like that you've labeled this here. Label this one on the right too here. So you almost want to make a table. It's like the root and then the degree of that root. So there's a root at -3, degree 1 because it crosses. There's a root at -3, but it touches, so that's degree 2. There's a root at 0, but it crosses, so we'll go degree 1. Think of degree as multiplicity. I don't know why I keep saying degree, multiplicity. And then at 1, it also crosses, so multiplicity of 1. So this first one corresponds to x plus 3. The second one, x plus 2 squared. This corresponds to just x to the power of 1. And this last one would be x minus 1 to the power of 1. I presume because you did this so well in this problem 5 that you understand this. But if it's not clear, please ask. So here's where we're at for a polynomial function, x plus 3, x plus 2 squared. Usually the x comes out in front, x minus 1. So you might think you're done here, and you'd be very close. Problem with this is that this is an odd degree here. And normally odd degrees, like if you think of a cubic, they start low and go high. This one starts high and goes low. So a negative x cubed starts high and then goes low. So yours probably has a negative in front. And we'll just confirm that here with the degree. So you just add up the multiplicities. So you've got 1 plus 2, that's 3 plus 1, that's 4 plus 1 is 5. So your degree you get by adding the multiplicities. So yours is 5. Since it's odd, we know that it's got to be going this direction because the standard odd goes up, so it must be a negative in front there. All right, I asked you to unmute there. Just give me some feedback. Let me know if this is okay or not.
Yeah, that works. This all makes sense.
Great. All right, so 7 is like a going backwards problem. So let me snip that in. All right, so the degree comes from adding up the multiplicities. So you got a multiplicity of 1 plus a multiplicity of 2 plus a multiplicity of another 2 there. Sorry, I don't like the way I did that. So these are the multiplicities, as you know. And that gives you the degree. You don't want to multiply it out. All right, so now we know for odds, and there's both odd and even, but odds start low and go high if the leading term is positive. So since the leading term here is positive, it looks like this. If it were negative, it would go the other direction. Okay, so this is for odds, and then usually a is the leading coefficient, so a greater than 0, a less than 0. There's also two graphs for evens that you need to know. I can draw those if you would like. Just let me know if you want me to do that.
We just learned them in class today, so I'm good.
Okay.
But thank you.
So determining the end behavior, this is really awkward for students, and I think I just agree it is kind of awkward here. So let me just grab this. So the way you write the end behavior is you actually write it out sort of in reverse. You say as f of x, and you got to figure this out, x goes to infinity. So I actually prefer to like start over here on the right as x goes to infinity. And that means as you're going to the right. So as you're going to the right, where does the y go? You can see that this goes to positive infinity, but it's written this way where you go f of x first, then x. Then you look at what happens when you go to negative infinity. So this means to the left. Let me say to the right, to the left. So to the left literally means like what's happening over here in this corner or up here in this corner, but you're going down to negative infinity. So that's, you write f of x goes to negative infinity like so. Any questions on that? If not, we'll jump to C, finding the y-intercept. All right, let's jump to C. All right, the y-intercept is when x equals 0. So you're just evaluating the function at 0. 3 times 0, 0 plus 1 squared, 0 minus 4 squared. Whenever you have 0 that you're multiplying by, because it's just x, the whole thing is 0. So this one is just 0. You don't have to actually evaluate the rest of this. You can just say it's 0. And it is an ordered pair, so make sure you list it that way. If you just write 0, you may or may not get credit. It may be unclear what you're doing. Okay, moving on to part B. So there are 3 zeros. There's one at 0. That's from the 3x. I actually like when you add the term here. The multiplicity of that is 1. And we already mentioned that when the multiplicity is odd, it crosses. When it's even, it touches. So cross. Then the x plus 1 squared, that's a 0 at minus 1. It's the number that makes the 0, multiplicity of 2, and it touches because it's even. The last one here is for x minus 4 squared, so 0 at 4, multiplicity of 2, and it touches like that. This is necessary to do the graph. So if they ask you to graph it and wow, that really didn't work out. Give me a minute here to clean this up. All right. There it is. Okay. If they ask you just to graph it, you still want to make a table or at least have some ideas. So you start with the zeros. You have one at -1, 0, and 4. Okay. And it's like, what happens at each of them? Well, at -1, it touches, but you don't know whether it comes down or comes up to touch. So to answer that question, that comes from the end behavior. Okay, that comes from knowing that since it's an odd, it has to start low and end high. So you actually, when you're sketching it, you actually start with those, because that tells you, okay, I come up and then I have to touch. And this one here at 4 also has to touch. So it kind of comes down. And then it's like, well, what's going on here? Well, at 0, it crosses, so it comes back, but then it has to come back down and touch again. So your teacher's not looking for cleanness. They're just looking to see, like, did you get the right cross and touch? And it could be a little awkward like that. It comes back down, goes back up, but we can do another example if you would like on this.
Sure.
Okay. Before we do another example, though, just quickly, do you want us to do any from the other page?
Can we go over the first one again? Because those kind of are confusing to me.
Number 1 or number 4?
Number 1.
Number 1. Okay. All right, calculator, okay. Are you using a TI 83, 84?
It's an 83.
Okay, and can I show you how to do it on the calculator, or do you already know how to graph this?
You can show me how to do it on a calculator.
Okay. All right. So I have a virtual TI 83 that you should be seeing now. Should be seeing. There it is. Okay. There it is. Okay. All right. So if you ever need me to show you some of the calculators, just let me know. I'm happy to do that. So we want to go to y equals, and this is where you type in that cost function, but you type in 4.9. Get this out of here. X squared. So x power of 2 minus 617.4x. You know how to do this. Plus 19,600. Now, normally I would ask you, like, what happens when you graph? And you probably already know when you hit the graph button, you'll see it here. It doesn't give you anything useful. Okay. So here's what you can do. You can go to zoom. And if you go up to zoom fit or go down to zoom fit, what the calculator tries to do is it tries to fit this into a window that it thinks is right. And it may or may not be reasonable. In fact, this is completely unreasonable, but it gives you a starting point. We know this is U-shaped, so we know that, like, this thing comes down, but eventually it's got to go back up. And that's where we actually go in and change the windows. So we're gonna change our X max. I don't know, I'm gonna go out to 50 for the moment. And then our Y min, let me just go 0. And this seemed too high. So let me just go to, like, I don't know, 10,000. You can play around with the scale if you want. Usually you go like 10% of the Y value or the X value. So in this case, 10% of the 50 would be 5. And we'll graph that here. So this is the absolute hardest part, is figuring this out. So you can see we still haven't gone out far enough. So we'll go back to the window and get that. Now, I know if you already have the window, you probably think, why is he doing this? You got to get the window. That's really super critical. So I went too far out that time. So it looks like maybe 100 will do it. Then we can get to the rest of this. All right. So notice it's really close to 0. I guess I should change my window just a tiny bit more. Y max maybe 1,000. So notice I'm kind of changing my factors of 10, and you don't just make big jumps here. Hopefully this gets a nice, there it is. Okay, I like that a lot better. So there's a couple of things that you might calculate here. One is the vertex, and your calculator will do that for you. All right, so to do that, what you do not want to do is use trace. You actually want to go to second calc, which is under trace, and then either the min or the max. You have to know this is a min. The calculator tries to help you. It says left bound, okay? And you got to kind of move left or right until you get there. What you want to do is choose something just a tiny bit left of this, meaning like this is good. Like you don't have to get too close or too far. This is just right. Hit enter, right bound, get right of it, okay? Then it says to guess, just guess wherever you are. You don't have to go back and try to get it perfectly. So when you see something like this, when you see like 62.99999, you're supposed to say, okay, that's really 63. Like do not write 62.999. Your teacher will wonder what you're doing. You've got to have some common sense with this. It's like, okay, it's 63. All right. So let me go back to the other screen here. Before I do that though, are there any questions on that?
No.
Okay. All right, so go back to the other screen here. So when it says how many clubs should be manufactured to minimize the marginal cost, they're either asking for the X or the Y value of the vertex. And that's where you have to kind of look in context. So in this case, X is the number of clubs. So in this case, part A is 63. Part B, and you got that. I mean, you actually got that answer perfect. Part B is asking for the Y value of the vertex. So typically in a quadratic, they're either going to ask you for the X or the Y value. In this case, it's 151.9, and that's just in dollars. All right. I can probably answer something in like 2 minutes. I do have to take a break between classes. Or anything else between lessons? Or is there anything else we can you'd like me to talk about or work through real quickly here before we close out?
I think you've covered mostly all of it. I think
Awesome.
I understand all of it.
Great. Let me go ahead and stop the recording here.